Yeah, good morning everyone, and welcome to Germany if you haven't been before. I am a native German living in America now, but welcome to Berlin in Germany if this is your first time. We will talk about Swift, microservices, and production. Like, Swift is a very new and very engaging community, but there isn't all too much out there about production environments yet. And we, Scalpo, have been doing this for a little over a year now. So what we will talk about is first a little bit of background in myself, then we will talk about currently trending solutions, an alternative approach, a hint, that's microservices, and then microservices and their architecture, use cases and examples, and how to start, just to give some people like a starting point of how you could use this yourself, and then Q&A. Let's start with the background. I started programming at 8 years old. That was BASIC back then, and Java was like the new trendy language. I started Scalpo with 14 and incorporated with 17, primarily doing consulting work. I myself am a weird mix between programming and business, so there's a little bit of both in this, and this is not going to be the most techie talk, but that's probably not too bad either. I am a German, and I like well-engineered products. So microservices really fit my nature. And over the course of my career, it so happens that I have built 5 and more social networks. One of them reached over 300,000 people in Germany at some point within the course of 2 months. All right, let's make this a little bit interactive. Who has ever maintained a WordPress site? Or Magento, Sharpware, Arxid, Typo 3, Drupal, you name it. That's quite a bit, so everyone is familiar with what that typically looks like. And so what are the most common issues with these systems? Because I think most of us will agree that it doesn't always go that smooth. This is what we call the plugin dependency hub, which is essentially when you have a WordPress site or any system and you install plugins, they offer you all kinds of functionality, but that's not always compatible. So you have a plugin here that does something and another plugin here that wants to do a similar thing or a different thing, but they don't interact all that well. And then you end up with trying to figure out how can I manipulate 2 plugins to really achieve what I want. Scripting attacks, especially since all the systems mentioned, but also the ones in other systems, are running off PHP or languages that leave a lot of room for scripting attacks, which in essence just means you are busy trying to secure your website in areas where you really don't want to. A monolithic complexity, which is in essence that all these systems are built up as one solid brick. So you have only PHP, and you have like 20,000 files in some cases with all frameworks and dependencies. So if you want to debug something or find a specific bug, it can take you quite a while to nail that down. Constant important updates. I'm sure most of you have experienced this too, that you see there is an update for a plugin and it's also important and great, but then we go back to point 1, plugin dependency hell, and we figure out if I update this, this won't run, and I tried that, and now I see a white screen here, and you try to juggle that. Overall, these systems are also known to be slow comparatively, because of many of the other points as well, but primarily them being in a slow language with a slow setup that comes from a time when a website used to be 3 files and 2 pictures, or something like that. How about a different approach? What is a microservice architecture? Talking to you guys yesterday and just getting like a general sense of where people are at, microservices are this thing most people have heard about. Not too many have directly interacted with it. Some have, but it's overall not the most familiar concept. The monolithic architecture is what we are used to, which is like a WordPress. You have one folder, everything is in there, everything is the same language, files, static files, user files, all of that thrown in the same folder, as opposed to a microservice architecture where we have different services doing different parts of the application and having all their own responsibilities, servers, folders, etc., being fundamentally different to the monolithic approach. That also translates into server setup. This is an example from Amazon Web Services of how that can look like. You would have a user interface typically as static content delivered through CloudFront, saved on an S3 storage, that then accesses through a load balancer different microservices that access different data stores. So that can be really handy if you have an application where you need different data stores. You could have a DynamoDB, you could have a rational database, or Elastic Cache, Redis, or whatever else you see fit, or running, and it is not directly connected to your microservices. What is a microservice itself? As you can see here as an example of a microservice architecture, a microservice could be anything that delivers a logical piece of a software. So for example, authentication. An auth service would be a service that exclusively deals with authenticating user requests and authenticating user access. A tracking service would probably do something along the lines of tracking. Monitoring would ensure that things are running fine and interacts that way, and so on. You see there are many services listed here. We will go into a bit of detail in each of them later, but the essence is each service does its own little piece of functionality and only that. Like a user service would not deal with content or would not deal with videos or media. Also, all of these can have their own independent data stores, as I said before, where, for example, the tracking service uses Cassandra, whereas the auth service uses Postgre. That is a very handy and nice feature, especially if the nature of the service requires a different way to store data. For example, a newsfeed may be better to be stored in a Mongo database, whereas users traditionally fit best into an SQL scheme. So you can pick and choose however you like it with a microservice architecture. A big application with many small pieces. The obvious benefits are individual care for each service. So we can pick different framework, languages, and tools for each of these services. We could use, for example, a Node.js server to do a specific thing where we feel like that's the best fit, whereas we use a Swift service for something else and a Go service for still something else. We can really pick and choose as so long as they work together. Separate teams and responsibilities, especially in bigger projects, it's extremely handy to have really strictly defined responsibilities so that one team exclusively deals with, for example, product management, whereas another team deals with the user management. The two teams will obviously interact, but they don't have to worry about each other. They can just do their own specific service, and that way you have an effective setup for a structure where more than one developer can deal with the entire application. Individual approaches for each service. As said before, we can have different databases and setups. For example, a user service that only manages the login for a user does not necessarily need the same amount of instances running as opposed to a content service that is delivering constant content. So we can, for example, have a setup where we say, okay, we have 3 servers running the user authentication and we have 10 servers running the content. It's very easy and possible with microservices to optimize the application based on demand. Disadvantages to a microservice architecture. This is something that has to be said as well because it's not a one-size-fits-all. No quick and easy fixed setup. So in WordPress and any of these traditional systems, you typically can fix everything yourself. You kind of figure out, oh, there's something messed up, I'll fix this. That's not necessarily that easy with a microservice architecture. As said before, we have shared responsibilities, but also very separate responsibilities. So if I'm responsible for the user system, I cannot necessarily fix the product system. And that's okay, but that is something that can be a hassle if we only have like 2 developers. There are many moving parts with microservices, and debugging can be quite painful. An example is in one of our recent projects, we have about 3 services that are directly connected to each other. If the last service outputs something that's obviously an error, we need to debug each one of them again to see where is this error coming from, because they depend on each other. So debugging can be quite a pain as well in a different way. It can require more developers than available. If you have a setup and you set it up to be with 10 developers, but then 5 of your developers are sick, you may not be able to fix it right then, or at least it's significantly harder. That's something to consider as well if you think about setting up a microservice architecture. And then it's not always that case, but it is often more time-consuming and expensive because of all the above, to fix something or add a feature in a microservice architecture is not as easy as installing a plugin. That is requiring each service to adjust and add a new piece of functionality that needs to be communicated, needs to be tested, etc. So microservices are great, we love them, but they are not necessarily the easiest solution. Now, why is Swift particularly well suited for microservices? I think this is a little bit of preaching to the choir because we are all here because we think Swift is great, so I'm just going through this really quickly. It's an easy language that is fun. It's a modern language with modern features. Frameworks that were built specifically with microservices in mind. All the frameworks that are popular are here at the conference, and I think we can all agree that they all at least thought about this some, if not primarily. Native apps, fast performance. As said before, all these other systems use PHP primarily, which is just comparatively extremely slow. We with Swift have an extremely fast performance comparatively. And we are all here. It's a strong community. There's support left and right, if you know the right Slack channels. And this leads us to ditching the off-the-shelf industry. The overall concept is that most projects start out with small requirements that grow bigger and bigger. For example, you start out with an online shop and you say, oh, I want to sell a few products. Okay, so you use Magento or Shopware, and it all works great for you. You have all the basic features that you need. But then you want to customize. You say, now I don't want to just show my shoes, I want to show my shoes in all their different colors in the overview. So you need plugins to make that functionality working. Now, in our experience, and we have worked a lot with Shopware specifically, that can be quite tricky to customize a system that is trying to meet like 90% of the requirements, but now we are going a little bit off. And now we need to dig into the core to figure out, hey, how can we not only show the main product, but also the variants in an overview? We want to modify themes for that too. Modifying themes is, in most cases, rather easy, but if you need a specific feature in your theme, you need to get a plugin or modify the core, which is always a bad idea, but it happens in reality, and then you end up with something that's not so off the shelf anymore. So you start with something where you think, oh, I can just plug my pieces in and it works fine. By the end, we have seen this many times over, you end up with something that's quite a mess because you have this partially, but you also have a bunch of individual pieces that don't work together so well if you update or do something with it. Reinventing the wheel. Henry Ford said that people, or he's supposedly saying that if he had asked what people wanted, they wanted faster horses, and so he invented the car, and we feel a little bit like Swift is kind of like that. If you ask developers on average what they want, they will probably say faster PHP. They probably want something more like this. Instead of using your choice of off-the-shelf software and modifying to fit your needs, you could build your own custom solution. Use templates and ready-to-go services and customize. What that means is to customize your solution based off templates that are already there. For example, we have developed a user service that's very fundamental. So it only does user authentication with a few attributes, email, password, first name, last name. You could use that and customize it to fit your needs. So you have a user service with whatever else you need in your solution, which is the customizing part. You don't need plugins for this. You really customize the given template, or you develop it all yourself. You could just say, we need like this really weird structure that plugs into another system over here, so we develop this ourselves. You will not need plugins. You also don't need updates. You update when you feel like it. There is no need to depend on other people's need for updates. Who is using such a structure? Microservices are really not all that new. They are really old. Lufthansa, UPS, and other old-fashioned big corporations have been using them for years, naturally, because back then and today, they have so many moving parts in different segments of their business, they can't just throw it all under the same hood, and so naturally they use microservices, though they may not call it that. But over the years, all our big friends, Facebook, Netflix, Google, Amazon, Uber, and Airbnb, as well as many others, have shifted. Most of these started out as monolithic applications that had one code base for everything, to then slowly and over time adapt a microservice structure to better fit their corporate structures, as well as user demands. And last but not least, smaller companies and startups start to embrace it as well. The benefits we just heard about, and now we will look at some use cases of real-life on-production services that we have developed and use. This is Fuelish. It's a German social network for people that are Fuelish, which is anyone who loves old-timers. And we have developed Fuelish out of an original PHP structure into a microservice structure. One of the features of Fuelish is you have news and stories, and it's very much like any social network. You have a news feed with pictures and videos and likes and comments and all this fun stuff. So we have all this, and we want to have microservices for that, which in our case meant we have 5 microservices involved in rendering this one page. A user manager who manages who you are, what are you allowed to see, a content manager delivering the content itself, a group service who delivers the information which groups you belong to also filter out which content to see, a media service to give you all the pictures and videos and sounds, and then a comments and like service that does all the liking and answering and commenting. As you can see, 5 services for one page. Now, another feature here is the drive-in tours. Users can create tours, which is essentially if you have an old-timer and you say, I want to drive from Berlin to Hamburg, you create a tour, people can join you, and then you all drive with your old-timers that route. Users can follow and participate, and tours can be recorded through GPS. Now, which microservices do we need for this? 4, user manager, group manager service, media service, comments and like service. As you can tell, this is almost the exact same list as before, and that's the beauty of microservices. We can use the same microservice for 2 different use cases because it's so small. It's such a small piece that can just be plugged into whatever we need it for. The content manager or the group service does not care whether this content is shown in a newsfeed or on a profile, on another page, and the comments and like service does not care whether you comment a group or a post or a picture. So we can have these services all doing their job and plug them into each part of the application where we need it for. Another use case example would be Review Sender, which is our own product, which is in essence, if you are a merchant on Amazon and you're selling products, Amazon doesn't notify you if someone leaves a review. So we do that for you. And this is quite a bit more of a complex application. We have a user service managing the users. We have a team service because most of these merchants have teams and different people in different parts that like answer the reviews or manage the inventory, any of that. We have an Amazon service that stores the actual products with their information. We have a review service, which is just storing the reviews. We have review aggregation, which is another service that will aggregate and collect reviews. We have review analysis, which is giving you some idea of what's going on in your products and reviews. We have an Angular 5 front end that is using all these services to show it, and we have various databases that store the data. Review management is a prime example to show the usefulness of microservices. One microservice is containing the reviews, so it does nothing else but store, here's a review for this product. One microservice is aggregating reviews, so this service goes on the product page, it's like, hey, I found 3 new reviews, write them in there. So service 2 is talking to service 1. Another microservice is analyzing the reviews. This service is just saying, hey, give me all the reviews for this product, what's the average star number, etc. And all 3 can have different configurations, which is really useful, because in this case, the microservice that is containing the reviews does not need to be as prominent as aggregation, because aggregation needs to happen on an hourly basis, whereas the containing is a part that does happen, but users access the reviews typically once a day or so. So we have one service running to contain the reviews, whereas we have 5 to 10 services running that aggregate the reviews. The analysis review is also only needed on demand because users click on, I want a report, now they get it. So all three services have different amounts of instances that they are running on because they are differently needed. How to start? Why and how would someone start with microservices? Scalpel microservices. We, over the course of the last year and a half, have developed a variety of microservices that we are published as open source. And we like to use them, and we do use them for products where we see them fit, or we develop new ones. A few examples here is a user service, which is doing all the user management for you. The content service, which is blog posts, news, static content. A product service, which is products and service offerings management. So if you want to have a shop and you show like products on that shop, this service can contain the products, filter them, go through them, deliver them, all of that. A comment service, which is what I talked about before, where you can have people comment and like your content. An order service, which is the newest edition, which allows you to purchase things. So you can say, this is, by the way, all of these are completely independent. So like the order service does not have to work together with the product service. We could plug that into a WordPress for all it cares. What it does is it takes in a product description, a price, and a user piece of information like the address, email, and so on, and just contains the ordering information. So it will say if this person bought it with a credit card or PayPal, and this is the product. Now, all of these you will probably need to customize. Like if you were to invent a new app and you think, oh, I really like this one, I want to use it, you probably want and will need to customize it. But that's, as I said, the whole idea of this new approach where you don't need a plugin, you don't need this off-the-shelf stuff anymore. You take what you get, customize it for your needs, and you run with it. And it works great. You can find all of these and some more in GitHub